Hello. Today I would like to talk about innovations in AI world. But first of all, we must remember that none of the algorithms have passed the Alan Turing test. So there was one that was behaving like a 12 years old child. And if it wasn't able to answer the question, it was returning the answer that, sorry, I'm only a child and I don't know everything. So, but in fact, it didn't pass the test fully. So this is the information that is crucial and we have to remember about it. Okay, so let's switch to the browser and we will continue the journey. So the first information is that Japan's Fugaku Supercomputer will be able to develop homegrown or generative AI. Actually, what is important to understand that this computer will be used in the future, and probably it is in use now, to actually train LLM for Japanese language. And you can see there is information that they will develop a large language model for generative AI that centers on the Japanese language. And the model will pull publicly available data from Wikipedia and other sources with a goal of producing more precise results in Japanese. And the project will partner with Cyber Agent, a Tokyo-based digital advertising company developing its own generative AI. And you can see the generative AI is rapidly gaining traction in Japan, but the so-called parameters needed to produce good results can run into the billions. So Cyber Agent announced last Wednesday an LLM that uses up to 6.8 billion parameters, right? So this is very, very impressive. Tokyo Tech and its partners will build an LLM incorporating roughly 100 billion parameters, and GPT-3, the language model adapted to power OpenAI ChatGPT, uses 175 billion parameters. A high-performance supercomputer is needed to build an LLM, but no private sector Japanese company possesses a world-class machine. And why? Actually, it's quite difficult to build such big LLM, and even the engineer from the IBM, I have some video over there and I will then provide you a link, that she mentioned that it's difficult to build such big LLMs just because it consumes a lot of power and it requires a lot of computing power. So only big companies like Fujitsu, like governments, for example, like Microsoft, Apple, Google, and I don't know, OpenAI, right? These companies or foundations, they are able to do that because they have money to make it work. And you can see that it's developing because currently ChatGPT cannot fully talk in native Japanese language with someone in Japan. I mean, it's able to return some result, but you know, Japanese language is quite complex, and that is why they're going to train it to make it work, to provide you a better answer. And each time when someone from Japan will type the prompt, and that's the reason of it. And it's quite interesting also that in the future, I don't know when exactly, because you know, this is the article that I have to pay for, but this is something that, you know, is quite interesting, and I decided to share with this. And if you want, you can of course pay for the subscription, and I really recommend it if you want to be on up to date. Actually, they are planning to link a quantum computer. And this quantum computer will be linked into the future, with the supercomputer Fugaku. So that's the interesting information, and all of this because we need to, you know, expand. We need to find more solutions, and for example, you know, to fight with cancer. This is a very good example. To analyze data and from people that are sick around the world, and to be able to find a cure for cancer. Actually, this is something that we can generative AI. We can use generative AI for. So it's able to analyze the data and return proper results. If we will train it properly, then it will be able to give us some clues, and maybe we will be able to find out the reason of the cancer. And actually, we know how it is actually working, but maybe some kind of way to cure it, to fight with it, and to make it work to provide a cure for it. And I know that there is a huge progress in this area, so I hope that this AI, actually those algorithms, they will be able to help us, and not only in this area, but this is one of the most important, I think. And of course there are other important things that we can use AI for, and we can try to figure out some answers and find out the solution for our problems. Very interesting information is that actually the supercomputer Fugaku is using A64FX. So actually it's ARM CPU, and you can see that A64FX was developed as a processor for the supercomputer Fugaku, and for the semiconductors, the 7 nanometer CMOS process technology of TSMC has been used. Actually, what is a TSMC? This is a company located in Taiwan. It's a Taiwan semiconductors company, and they are using a technology to produce chips, actually, right? And they are using the EUV systems, actually, that are able to produce those superconductors, actually. And the company that produce EUV, the only one in the world, is ASML, located in Netherlands. So they are producing EUV. They are selling the EUV machines to, for example, TSMC, Intel, probably other companies. I remember that there are 5 companies in the world they are selling to, and yeah, Intel, and also Samsung, and yeah, and Taiwan Semiconductors Manufacturing Co. Those 3, they are the biggest, and I don't remember the last 2. However, ASML, they are selling those machines to them, and thanks to this, they are able to produce semiconductors and develop it in their companies. Why I'm talking about this? Because you need to understand one simple thing, that those companies, they are, I mean, TSMC, for example, is producing chips only for external contractors. And that's why, for example, if Fujitsu will ask them, will of course sign a contract, and they did it, so they produce chips for them, and because they have a technology to do that. And that is very good, because we can expand. Thanks to this, we have a supercomputer, right? And the other companies like Intel, they can also produce chips, right? And then they buy EUV machines, and they are able to produce, and actually each personal computer have Intel processor inside, almost, because we have also EMD company that is also producing chips and CPUs. So we can use this in our computers. So actually this technology is on a daily basis in use, and we are using it, and that's the reason I'm talking about this, because this is something you should know, actually, that such companies are existing and they are producing it. And one most important thing is that, for example, China is dependent on this technology, and because they don't have EUV, they don't have companies like TSMC, for example, or Intel on China's territory, they have to buy CPUs from companies, right? So this is the crucial information, and they are dependent. Probably they will be able to, maybe in the future, to produce chips on their territory. I don't know that. I'm not sure, because this is technological race, and it's hard to say how it will be, because for now I'm observing the situation that United States of America is trying, as a country, the government is trying to keep China away from this, and they don't want to let China to be able to produce semiconductors and CPUs, for example, right? And that's the reason. And it's not on government level, but it's also crucial information that how everything is working. So that's the information that's important for us. And how it will be in the future, I don't know. I mentioned in the previous tutorial that Chinese they have a Fugaku 2.0 LLM, and it is the biggest one, and they are trying also to produce a supercomputer or quantum computer that will be able to handle billion of operations, and thanks to this they will be able to train AI in their country. So that's how it is working currently in our world. The second information that is worth to mention, it's a Mojo. It's actually a new programming language for all AI developers. And what is interesting, if I will scroll down, you can read about it, is this table, this comparison. This is incredible. This is a speed up vs Python comparison, and you can see it's faster, much faster, 35,000 times faster than Python. This is something really incredible. You can see we have Python 3.10. It's a speed of, this is the language that is faster than Python 3 actually. Not Python 2, but Python 3. This is actually the Python 3.10.9 this version, and there is a comparison. There is also a PyPy and Scala C++. And you can see Scala C++ is also faster, but 5,000, and we have 35,000. This is really incredible improvement. So that I am shocked actually about the speed, and that's why I interested in, because I am learning Python all the time, because it's a very good language for AI. But as you can see, the comparison, the speed is interesting. And those people who actually knows pretty well Python, they can try Mojo or switch to Mojo. And this is also the good direction if you want to then in the future train large language models. So probably Mojo will be an answer, because the computing power, as you know, it's also important. And if the language speech actually allows you to perform operations faster, then you have better option, right? You have better solution. I mean, okay, the language is faster, so we can do the improvement by using Mojo instead of Python, for example, or PyPy or Scala C++. So I'm really impressed. I have to confess that this is incredible. And you can see how it is working. Actually, you can see the model extensibility. So Mojo can upgrade the existing operations in your model, and you can see how actually it is working. And input layer, hidden layers, and output layer, how it looks like. And this is actually an algorithm. I mean, one-to-one when it's communicating each, and that's something quite interesting. And also below you have information that the level of entrance, right? It's not high. I mean, if you know Python, it's easy to get started for you. But I think that even for someone who doesn't know Python but is programming in, I don't know, Java, C++, the switch will be quite easy. And of course, you have the community. So I really recommend to you to find out how it is working, and eventually switch to Mojo, because I think it's the future. This is my opinion. That's the reason I'm trying to learn Python, and then after that I will try to learn this one, because for myself, maybe I'm not sure will I be able to work in the future as a Mojo programmer. I do, but knowing something like this and using even in your home laboratory, this is something that is worth to learn and to find out how it is working, to see improvement, and only also for maybe for those who are paranoid and they do care about the privacy. So instead of using like open wide solutions like ChatGPT or Bing Chat, right? And there are people who prefer have own large language model, but I mean on the small scale in their home laboratory, and for example they can train it if they are very good developers on a small scale. For example, I don't know, some kind of knowledge base in the area they're working at, right? Some examples, things like this. Okay, so thank you very much. Have a nice day. Take care. Bye bye.